Speculative decoding. What is it? Let's say we have a sentence. The scientists discovered that blank. We want to predict the next 6 tokens. So we feed this to a large language model, which we'll call the target model. The target model predicts the next token, bees. We repeat this 6 times, communicate with a wiggle dance. This is slow because we have to run the whole model to generate 1 token at a time. Now, what if we had a smaller, faster model called the draft model that generates tokens really quickly, but with lower quality? Bees communicate using a buzz sound. This isn't accurate. But what if we could use our target model to accept or reject these drafted tokens? That's the idea behind speculative decoding. Draft quickly, then validate all at once. Now let's take it step by step. The draft model generated 6 output tokens. We feed these into the target model, which produces a probability distribution at each token position. Here's the distribution where bees is sampled, which is different from the draft model distribution. To decide whether to accept or reject a token, we use this acceptance formula, which compares the target distribution to the draft distribution. When the target model probability is higher than the draft probability, we're guaranteed to accept, which is the case for bees. And the same for communicate. When we get to using, the draft probability is a bit higher than the target one. So we have an 80% chance to accept. In this case, we accept, and similar for A. However, when we get to buzz, the draft probability is far higher than the target probability. We only have a 20% chance to accept, and in this case, we reject. When we reject, we resample this token from the residual distribution, which is the difference between the target distribution and the draft distribution. In this case, we sample wiggle and discard the rest of the draft tokens. We could then repeat the same process, continuing from wiggle. So why this acceptance formula? Here's our target and draft distributions. The minimum of them represents the probability mass that's guaranteed to be accepted. When the draft exceeds target, tokens have a probability to be rejected, and when they're rejected, we resample from the residual. You may notice that this resulting probability distribution exactly matches the target model distribution, so we're guaranteed to generate the same tokens as the target model. So how much does this speed things up? Here's the demonstration, with the target model generating tokens one by one sequentially, and the model with Spectec generating tokens a variable amount every time. Here you can tweak K, the number of draft tokens to generate, as well as chance to be accepted, and the speed of the target and draft model. To see how much speed up you can expect with Spectec, the visualization simulates this with a 10-second rolling average. You may notice that the actual speed up varies a lot, depending on how lucky you get with how many draft tokens are accepted. That's speculative decoding. If you want to interact with these visualizations or read through it in more depth, check out the interactive written version. Link in description.